Hey there, welcome to VCode's 100 Days of Coding Challenge. Today is day 7 and let's see the question number 1. So the question is, develop a Java program demonstrating method overriding and dynamic binding. We need to create classes for shape, circle and rectangle to showcase method overriding and dynamic method resolution. So these are two new words, method overriding and dynamic method resolution. So the description is given that we need to construct classes called shape, circle and rectangle, and we need to implement a class called calculate area in the shape class and override it in the circle and rectangular subclasses to showcase dynamic method binding. So what are actually these method overriding and dynamic method resolution? Method overriding, we had actually seen it already in the polymorphism. So there are two types of polymorphism. One is compile time, the other one is the runtime. The compile time polymorphism is the method overloading, which we had solved in the previous videos, and the second type which we are going to see today is the method overriding, which is the runtime polymorphism. I'll discuss it shortly. So also we have the new topic called dynamic method resolution. So here we have the same question that we need to create a class shape and two subclasses, which is circle and rectangle, which has the method called calculate area, and we need to override that method in the circle and rectangular classes. There is no particular input format. The output will be, we need to display the area calculations invoking the calculate area method for the objects of shape, circle and rectangle classes to highlight the dynamic method resolution. So the test cases. So what actually we need to perform in this question is, first thing is we have to instantiate objects of shape, circle and rectangular classes and call the calculate area method for each object and which demonstrates the dynamic binding. So I'll first explain what is dynamic binding and then I will demonstrate how it is working in the code. And the next thing is we need to override this calculate area method, which we'll do in the circle and rectangular classes, with unique area calculation formulas and which exhibits the method resolution during the runtime. So this is about the dynamic method binding again. And the third one is show how the same method called to calculate area produces different results for circle and rectangle. So this is because of the method overriding. So these both concepts, overriding and dynamic method binding, are interrelated. So let's see what are they. So actually, as I already said, this method overriding is a runtime polymorphism. So what does it actually do? Polymorphism means actually performing the same task in different ways, right? In method overriding, we will be having a method in the parent class and we will override the same method. For suppose let's take the same example. So if we have something called shape, so we have two subclasses, which is circle and rectangle. In the circle class, the area would be pi r square. In the rectangle, it would be length into breadth. So I will have the same name for the method, but the implementation or the area calculation will be different in both the cases. So that is about method overriding. We are going to override the method in the parent class, in the subclasses. The next concept is dynamic binding. So dynamic binding is a concept where we are going to, where the JVM is going to identify the object's type in the runtime rather than the compile time. So you will understand this more in the coding part. So that is about dynamic binding, and dynamic method resolution means which method implementation would be invoked during the runtime is the dynamic method implementation. The overriding means we have overridden, but according to the object's type, we have to know which object's class method should be invoked. So we will see that also in the coding part. So let's quickly write the code. So as the question is about the shapes, I am going to create a shapes class. So shapes.java, and here we will be having one main method. Okay. So now, okay, so here it would be shapes. So now let me create a class called shape. So this shape will be having a method called calculate area. So void static void calculate area. So let it be non-static because anyways we are going to create an object. So for the shape method, I'm going to just display a sentence. Area is calculated because we don't have certain formula for the shape because it is unknown. So now I will create two child classes. One is the circle, which extends the shape class, and the other one is rectangle. So class rectangle extends the shape class again. So these both classes will be having the calculate area method. Before that, let us declare the attributes or what properties does it have. It has double radius, and I will call the constructor to assign the value for that object. So radius, this dot radius equals radius. Now what does rectangle have? It has double length and width. We can actually declare it in the same line, and both of these have the double type. Now I'll write the rectangle constructor. Rectangle, and now this will be having double length and double width, and this dot length equals length, this dot width equals width. So what these classes will be having? So these both classes will be overriding this method. That means the same return type will be same, the name of the method will be same, the parameters will be same. Everything will be same except the implementation, and that would be according to the class. So this is a circle class, so the area calculated will be according to the circle, and this is a rectangle class, so the area calculated will be according to the rectangle. Now let me write the, let me copy this void calculate area and I'll paste it here. So here what we will be printing is, what is area of circle? It is pi r square, math.pi into radius and at the rate override. And now here what we'll be having is, so I'll copy this and paste it here. So what is the radius of, what is the area of rectangle? It is length into width. So it is done. So I have written the same method name, return type as well as parameters, which is no parameters in this case. And I have written different implementations in different classes. In circle it is pi r square and it is in length into width in rectangle class. Now I'm going to create two objects, one for the circle, let it be C1 equals new circle. So it is circle. Let me give the radius as 7 and let us remove this. And the other object for the rectangle class, so R1 equals new rectangle. Let length be 10 and width be 5. Now I'm going to call the method calculate area for both these objects, R1 dot calculate area. So what do you think will be printed here? So here C1 is an object of the circle class and R1 is an object for the rectangle class. I'm also going to create a object for the shape class and invoke the area method. So shape, some shape equals new shape and S1 dot calculate area. Okay, so this is shape, right? Shape. So now let me write it at the first. Now let me run the file and check. So first of all, compile the file, shapes.java and java shapes. You can see, first of all, the area is calculated is printed, which is where the shape object which is of the parent class is called. So here the object shape belongs to the shape class and that area is printed, which is area is calculated. And then the C1.calculate area. So C1 is an object of circle class. So the area present in here is printed. So what is that? Pi r square. And that is calculated and that is printed. And then again I have given the same name for the rectangle object belonging to the rectangle class. So the method in the rectangle class is implemented, which is length into width. So this is how method overriding works. So what about dynamic binding? So let me now create an object shape from the class shape and let me name it as circle equals new circle, and I will give here the radius as 10. So what do you think will be the output for this? This is a circle where the class name is shape and the constructor called is the circle. So I will now call circle.calculate area. So here comes the concept of the dynamic method binding. So let me run the file and show you. First of all, compile the file. So when it is compiled, the JVM will understand that this circle belongs to the shape class, that this circle is an instance of this shape class, but it won't know that it actually belongs to the circle class and a circle is actually created. So that happens actually in the runtime. Now when I run the file, we will get an output we will get the output. The area will be calculated according to the method present in the circle. So now let us see. So you can see here I have got 314 and so on, which is 10 square into 10 square is 100 into 3.14, so 314. So this actually happens because of the dynamic binding. So dynamic method binding. So this is a mechanism where the JVM will understand which method should be implemented at the runtime. So here why didn't it implement the calculate area method present in the shape class? That is because during the runtime it will understand that actually a circle is created here. So the circle method should be called. So if the dynamic method binding concept was not there, then we would have got the output that area is calculated, which is the method present in the parent class. So that is the use of dynamic method binding. So that's it for this video. We have learned how to do the method overriding and also we had learned the dynamic method binding. So that's it for this video. Do follow the 100 Days of Coding Challenge by VCode. Thank you for watching.